In the last part of the lecture, we are going to briefly talk about communication using inductive coupling and light. So we are just going to give you a brief overview of these two important topics, but we are not going to cover them in great detail in this course. So to understand visible light communication, I'll take a case study for one of the systems that I had developed together with colleagues in Spain, which was presented at a major conference, ACM Mobisis in 2020. So we designed this system called Edison, which was able to communicate using visible light, using downlink communication through light, and support uplink communication through backscatter mechanism. So this device is able to receive communication using the small solar cell and also harvest energy. And it's the energy is stored in a small capacitor which powers the electronics on the board, and it uses the backscatter mechanism which we had seen in the previous lecture for it to support uplink communication. So how does this system work? So you absorb energy through the solar cell, which goes into the capacitor bank where it is stored, and then you regulate this voltage and then use it to power a microcontroller and the backscatter module. And all of these operations are being performed just from the energy that is harvested from solar cell and stored on a capacitor. So overall, what we were able to demonstrate was that we could communicate using visible light at low bit rates, have a device that is operating on energy harvested from this light, and communicate using backscatter mechanism. So by having this sort of like hybrid communication medium where you are using visible light for downlink and backscatter communication for uplink, we were able to have a device that is without batteries and just operating on energy harvested from the environment. So by having these low power communication mechanisms like LiFi or as well as backscatter communication, that we are approaching a point where we can have this vision of sustainable IoT devices. So next, we are going to quickly also talk about another backscatter-like mechanism which we actually use in our day-to-day life. And this is basically something that actually uses inductive coupling. So what happens is that if you have two coils that are close to each other and there is a change in current through one of these coils, it also induces a change in the current in the other coil. And this can be used to both provide energy as well as for these to enable communication between these two coils. And typically, these coils are having the signal generated at a very low frequency of 135 kilohertz or up to 13.56 megahertz. And it can transmit through materials, including skin, but it can be sensitive to metal. And typically, it has short communication range. So one of the standards that actually employ this inductive coupling is something called near field communication. And we use this actually in our day-to-day life, for example, to make payments. If you, let's say, go to a store and you want to make payment through your phone, you keep your phone next to the payment terminal. Typically, it's using an NFC technology, which is based on this inductive coupling concept to communicate with the reader device and make the payment. It is also, for example, used in things like in buses for you to, when you flash your card, and it's using NFC to sort of like communicate with the reader device on the bus itself. So it's not based on backscatter mechanism, but it's very similar in a way that it's communicating through these electromagnetic signals, and also having the device being powered through this these signals, and the end device can be without batteries. So with this, we come to an end of this particular lecture. Thank you very much.